All right, this is part 2 of graphing tangent and cotangent graphs. So our first example is going to be graphing two periods of the following equation, which is a tangent graph, and that's important to note because now we know in our heads what it should probably look like. So we're going to go ahead and start by just identifying characteristics, just like we did with the sine and cosine graph. So let's start by figuring out well, some things are easy to see. Like we know that A is equal to 1/4. And just to remind you guys, what's that going to do to our graph, that A value? Well, that's going to affect these 2 points here, other than the one that's in the middle. Okay. The next part we can do is we can figure out what is our starting X value. And for tangent graphs, we said that we're going to set that equal to not 0 this time, but negative pi over 2. And if I solve for x here, I could divide both sides by pi. I can multiply both sides by 4. So I get x equals negative 2. And again, and I'm even going to write a note, just because it's our first time doing this, is that's our starting x. Okay. In this case, we don't have anything added or subtracted, so we don't have a vertical shift. Let's figure out our period. So remember, for the period, we said do pi divided by b. And b is that term that's multiplied to x. So I'm going to have pi divided by pi over 4, which gives me 4. And last but not least, want to figure out, well, what are our intervals on the graph going to be? And remember that that's just our period divided by 4, which in this case is 1. Okay? I'm pretty sure that's all we need. You know, if we were asked to find, so we found our starting x value, you only need to either find the horizontal shift or the starting x value to graph, not both. But, you know, I would just recommend being prepared to answer both if it asks. If it does ask for the horizontal shift, then we're going to set this equal to 0, which would be 0. But we don't need to do that. Okay, so let's begin. Since I know it's going to start at negative 2, I am going to leave some space for myself, you know, on the left side here. So let's start by doing this. I'm going to go up to 1/4 and down to negative 1/4. I know that my starting x is at negative 2, and then my intervals go by 1. So I'm going to go negative 2, negative 1, 1, 2, 1, 2, 3, 4, 5, 6. I'll extend that line a little bit. Perfect. Okay. So next, let's get something good here. Next, let's worry about our asymptotes. Remember, our starting value is going to be an asymptote at negative 2. Okay. Next, we know that our period is 4, so I'm going to go 4 units away, so that goes to 2. I need 4 away from 2, which is why I went all the way out to 6, is because remember we've been asked to graph 2 periods. Okay? Now I gotta finally put things into my graph. So remember, we start at 0, 0, the origin. It's positive. There was no vertical shift. So I can just go up to 1/4 and down to negative 1/4. Same thing here. And then I'll fill in my curve. Sweet. Not too bad, right? I can tell you're having so much fun. Okay. Next one. Graph 2 periods of y equals negative 2 cotangent of 3x minus pi. So what I'd like you guys to do right now is I'd like you to identify all of those characteristics on your own at minimum. You can go ahead and try to graph it, but at least on your own, let's start getting used to, like we were before, identifying those characteristics. So go ahead, put me on pause, and then we'll check if you got it right. Okay, so let's see how you did. So our A value, which affects, it's not our amplitude, remember, but it does affect, these 2 points that we would have here is -2. Here to find my horizontal shift, it's going to be a pi over 3. So that's where my first asymptote will be. Vertical shift is none. Period is pi over 3. And intervals, I have to take that period and divide it into 4, which is pi over 12. So you guys can see how I have started my graph here. If you're wondering about these intervals, remember we said start at pi over 3, and then the intervals need to be pi over 12 apart. And if you're struggling with that, well, think of what pi over 3 is with the denominator of 12. That's 4 pi over 3. So 4 pi over 3, 5 pi over 3, 6 pi over 3, sorry, over 12. Man, I screwed that up. Well, hopefully you know what I meant. If not, whoopsie daisies. Okay, so let's start by putting in our asymptotes here. Remember we said we'd start at pi over 3. I don't know why, but this is my favorite one, this purple. We said that our period is pi over 3 apart. So the next place I'd go is going to be 2 pi over 3. And then last but not least, 3 pi over 3, which is pi. Now here's where we might cause mistakes is because, said that weird, we have a negative, okay? And we know because of our intense knowledge that this graph of cotangent would normally go down like this in contrast to the tangent graph. But because of the negative, it actually does look just like a tangent graph. So I'm going to go here, here, and here. I didn't really make that curve well. Hopefully you did better. A little bit better. Okay. And those are my 2 periods. One more example. All right, last example here, same thing. I'd like you guys to try this on your own. I'd even like you guys to try putting the actual graph together. Notice that there will be a difference here because we have that shift of -1, but I'm confident you guys can handle it. So at minimum, try setting up, all of our characteristics first. Also try to graph. Go ahead, put me on pause. All right, so you guys can identify my characteristics here. See if they're the same as yours. A, I had -3/2. When I set this part equal to negative pi over 2, because it's tangent, I get -3. That's my starting x, which is where my first asymptote is. It does have a vertical shift of -1, which is why I just made this new, what's that word I kept using before? Something about the ground. Middle ground. At -1, the period is 2, and the intervals are by 1/2 because I divide the period by 4. So remember, this is negative, so this graph's actually going to look like a, you're right, cotangent graph. Oops, imagine that I didn't just draw that there. Oh, man, I gotta really put this all over. Oh my goodness. But anyway, so when instead of starting at 0, I'm actually starting at -1. Okay, instead of going up, I'm actually going to go down to -5/2 and then up. Same thing here. Good, fill in my curve. Okay, sorry this is so long. Bye.